Okay, so now we know that yi is equal to beta 1 hat plus beta 2 hat xi plus ui hat. If I have to write everything in the mean form, I have yi bar is equal to beta 1 hat plus, so the mean of ui hat is 0, so it becomes 0. So if I name this as equation 1 and this as equation 2, and I subtract 2 from 1, we get yi minus yi bar is equal to, so this becomes 0, beta 2 xi minus xi bar plus ui hat. So this becomes small yi is equal to beta 2 hat small xi plus ui hat. So this is called the deviation form that you might see in the book. Now this deviation form has a very important property, that it would reduce the entire thing in very small amount, compact amount. So I get everything in the compact amount. So now what happens is, if I have yi hat is equal to beta 2, if I have yi is equal to beta 2 hat xi plus ui hat, then I know that this is small yi hat. So small yi hat becomes this, because yi hat was something which is without the error term. I'm talking about that. I'm talking about the sample form of the expected value, so that becomes only beta 2 hat xi. Okay, so another property which we should remember is that the residual term is uncorrelated with the predicted yi's. So if I have to show that something is uncorrelated with something else, it would be sufficient to show that the sum of the value of the product of the two things is 0. So if I'm able to show that summation ui hat yi, or predicted, which is yi hat ui hat product, if this is 0, if I'm able to show this, then I'm able to show that the two things are uncorrelated. Why? Because correlation is basically nothing but covariance of the two things upon sigma of the first thing and sigma of the second thing, and covariance is nothing but summation of something from its mean. So if we remember the formulas, we know that covariance of xy is nothing but summation of x minus x bar y minus y bar upon n. So this is nothing but summation small xi. Why? If I prove this equal to 0, then also I'm done. If I have to prove that covariance is 0, why covariance? Because I know that correlation is nothing but covariance upon sigma x into sigma y. So because of all these formulas, if I am able to prove that the product of two things from their deviation form is 0, that is, this is 0, then I am actually able to prove that the correlation is 0. So I can write summation yi hat ui hat as this, because we just proved that summation yi hat is nothing but beta 2 hat summation beta 2 hat xi. So if I take summation on both sides, this becomes this. So beta 2 hat is nothing but summation xi ui, and I know that ui hat is nothing but yi minus beta 2 hat xi, because in the deviation form we remember that small yi is equal to beta 2 hat small xi plus ui hat. So from here I know that ui hat is nothing but yi minus beta 2 hat xi. If I open the entire thing, this I will get this, and this is nothing but the second equation of the OLS, and I know that if this satisfies the second equation of OLS, then this should be 0. So hence we are able to prove that the correlation is